Graphing quadratic inequalities. Your first step, you're going to plot the vertex, the y-intercept, and the x-intercepts of the inequality. So we're going to do that first. Here's our first inequality. In order to find the vertex, you use the equation negative b divided by 2a. So let's figure out our x-coordinate by using this formula. So my b value is -4. This is my a value, 1/2. So I'll put negative b over 2a. This becomes a +4 over 2 times 1/2 is just 1. So we get 4. So that means my negative b over 2a is just 4. Thumbs up if you got that. Great. All right, to find the y value, you plug 4 into all of these x's. So I'm going to erase these x's and plug in a 4. So let's think. 4 squared is 16 times 1/2 is 8. Minus 4 times 4 is 16 plus 12. 8 minus 16 is a -8 plus 12 is 4. Did you guys get that? Okay, great. So your vertex is 4, 4. I'll go ahead and plot that right here. Is it going to face up or down? Up. So it's going to look something like this, but let's be sure. I know it's going to face up, so that means what do I know about my discriminant? I know it's going to face up because this a value is positive. So what do you know about the discriminant? Exactly. Because there's no x-intercepts, I know that my discriminant is negative. Okay, let's prove that. The discriminant is b squared minus 4ac. So my b value is -4. My a value is 1/2. And c value is 12. So 1/2 times 12. Okay, so -4 squared is 16 minus all of this. 1/2 of 4 is 2. 2 times 12 is 24. So this becomes a -8. So if you use the quadratic formula, which is x equals -b plus or minus square root, you put the discriminant inside there all over 2a. I'm going to get an imaginary number because I have a negative under the square root. So that means we're not going to have any x-intercepts. Okay, so x-intercepts, I'm just going to put none. It's facing up. It won't go through the x-axis because my discriminant was negative. So there's no x-intercepts. Okay, the last thing we wanted to find was the y-intercept. And what is my y-intercept? 12. It's always your c value. So that's my y-intercept, 0, 12. So it'll be somewhere up here. So I know my graph will look something like that. Okay, now, before I draw that, because I drew that too fast, my symbol, let me circle my symbol. This is a greater than symbol. Let's go back to our notes. We did step 1. Step 2, we're going to graph using a dashed line if we have these symbols, and we're going to use a solid line if I have these symbols. So let's go back. I do not have a line underneath. This is a greater than symbol, so I need to do a dashed line. So guys, if you already drew a solid line, you need to erase it and put a dashed line. That is the greater than symbol. So I'm going to put my pencil or my pen on my line and go straight up because I want to be greater than the line. So you're going to shade up from the line. You're going to shade up. Go straight up from your line. So this is the part that you're shading. So going back to the notes, we did that part and we just shaded. So for all of these, you want to make sure y is on the left-hand side. Whenever you have these greater than symbols, greater than or equal to symbols, you're going to shade up, and you're going to shade below the line whenever you have a less than or less than or equal to symbol. So you substitute B in A. Substitute B with a -6. Substitute A with a -1. So this becomes, two negatives becomes a +6. 2 times a -1 is a -2. So this is -3. That is the X value of your vertex. Then you should be plugging in a -3 into your function to figure out what the Y value is. So -3 squared is 9, and it becomes a -9. -6 times a -3 is +18 minus 13. What does this become? What's -9 plus 18 minus 13? -4. So that is my vertex. Thank you. So I'll go ahead and plot that right here. Is my graph going to face up or down? Yes, it's going to face down. Why is it going to face down? Yes, your A value is negative. You guys have this negative in the very front. So I know it's going to face down, and my y-intercept is -13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be right here somewhere. So it's going to face down. Do I have any x-intercepts? No, because it's facing down. It's not going to cross this. So there's no x-intercepts. I'm going to put none. And I'm going to say because, can you guys give me a reason why? Exactly, because the discriminant is negative. That's why we won't have any x-intercepts. Remember, the discriminant is b squared minus 4ac. So that will be negative. We know the y-intercept is 0, -13. Okay, so this is what my graph looks like. And it also says this is the greater than symbol. It's the greater than symbol. So you're going to shade up from your line that you just drew. You're going to shade up. Go up from the line. So this is the part that's shaded. All of this that's outside is shaded. So let's talk about solutions. I'm going to give you guys some points, and we're going to see whether there are solutions or not. Solutions are always on shaded areas, and they're on solid lines. Okay, so -1, -6. -1, -6 is, let's see, 1, 2, 3, 4, 5, 6. Is that a solution? Yep, it's in the shaded part. So this is a solution. I'll put a check. -4, -8. Let's see. One, 2, 3, 4, -8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Is that a solution? No, it's not in the shaded area. -6, -10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Is that a solution? Nope, it doesn't look like it. I might have drawn it bad, but I don't think it is. Okay. And next one, -2, -5. -2, 1, 2, 3, 4, 5. That's on the line. Is it a solution? Yep. Yes, because why? Yes, it's a solid line. It's greater than or equal to. Perfect. So if it's on a solid line, please write that down. If it's on a solid line, if on a solid line, it is a solution. Now, if it was a dashed line and it's on a dashed line, then it is not a solution. Okay, so this, if you had something that looked like this is not a solution because it's on a dashed line.